Okay, we're going to look at 7.6 and 7.7. This used to be one section, and the new book has divided into two, but we're going to still learn it together. So let's start with 7.6, ratio and proportion. And what is a ratio? A ratio is basically a comparison of two numbers. So for example, the probability when I flip a coin that'll be heads is 1/2. That's a probability, but the ratio, it's also ratio 1/2. When two ratios are equal, they are in proportion. And so we're going to solve a couple of proportions. So let's look at this first one. It says it takes 80 pounds of sodium hydroxide to neutralize 98 pounds of sulfuric acid. And let's say you have 47 pounds of sulfuric acid. How many pounds of sodium hydroxide are needed? There's many different ways to set up this proportion. As long as you have the same units in one fraction, the same as on the other, you're okay. So what I'm going to set it up as is that the 80 pounds of sodium hydroxide is needed to neutralize the 98 pounds of sulfuric acid. Since I have sodium hydroxide on the numerator, sulfuric acid on the denominator, I need to do the same thing over here on the second fraction. So I have 47 pounds of sulfuric acid. That needs to go on the denominator, just like the 98 pounds is the sulfuric acid. And then what I'm trying to find is how much sodium hydroxide I have. So this is the proportion that we're going to solve. Now I could multiply by the LCD over 1 like we did in 7.5, but because there's nothing added or subtracted to either one of these fractions, it's just one fraction set equal to another, kind of the shortcut way to do that is to cross multiply. So I multiply this numerator times this denominator, and then set it equal to this denominator times this numerator. That's cross multiplying. So when I cross multiply, I get 98x equals 80 times 47. And a lot of times I'll use my calculator at the very end. So the next step I would do to get x by itself is divide by 98. So you have 80 times 47 divided by 98. And then just put that into your calculator and you get 38.4. I'm going to round to one decimal place. And then this is a word problem, so don't forget your units, pounds. So you need a little over 38 pounds to neutralize that 47 pounds of sulfuric acid. Okay, let's look at another example. In this case, we're going to have a triangle, and we are told that triangle ABC and DEF are similar. That means their sides are in proportion to each other, and we want to find the length of side DF. So I'm going to put an X here. This is the side I want to find. And again, there's many different ways I could set up this proportion. I could say 9/3 equals x/2. I'm actually going to do triangle to triangle. So the long side here is 9, goes with, for the other triangle, x equals the shorter side. Since I started with 9, so I started the triangle ABC, I have to start with this 3. You can't switch. So it'd be 3 over this side of DE of 2. I'm going to go ahead and cross multiply 3 times x, bring down the equal sign, 9 times 2, which is 18. And this one, you don't even need your calculator. Divide both sides by 3, and you get x is 6 inches. So side DF is 6 inches. Okay, we're going to look at another motion problem. So again, I have a table set up, and we're going to fill it in with distance, rate, and time, and then we'll set up our equation to solve. So Mike leaves his house traveling 2 miles per hour, and Joy leaves 6 hours later to catch up with him, traveling 8 miles an hour, so she's going a little faster. How long will it take her to catch up with him? So let's start with distance. I don't know the exact distance either one has traveled, so I'm just going to put distance for Mike, and that's an M, distance for Joy. I do know their rates. Mike's is 2, and notice I leave the units off when I'm filling in the table. And then for Joy, it's 8. And then I don't know their exact time, but I know that Joy leaves 6 hours later. So that means if Mike's time is t, hers has to be 6 less. So hers would be t minus 6. And I'm going to do the same thing I did before. Once I've filled out my table, I'm just going to rewrite these two equations. So Mike's distance equals 2 times t, and Joy's distance equals 8 times t minus 6. Okay, now I'm going to figure out how to set up this equation. If I'm looking for when they're to catch up, that means Mike leaves and he travels for a while, and Joy leaves later from the same spot and traveling. I want to know when they catch up, so that would be right here. That means their distances are the same. I want to know when their distances are equal to each other. So that means I can set this first distance equal to the second distance. So this is what I'm solving for. Now we'll go ahead and distribute the 8. And we want to solve, that's a minus sign there. So to solve, I'm going to subtract 8t from both sides. And we get negative 6t equals, don't forget that negative sign in front of the 48. Divide both sides by negative 6, and you get t equals 8. And this is word problem, so don't forget your units, 8 hours. So take 8 hours for them to catch up to each other. Okay, now let's look at 7.7, which deals with variation equations. And we use these all the time. Let me just give you one example of a variation equation before we look at the specific examples. Area of a circle is pi r squared. This is a variation equation. You have your constant, in this case it's pi, and then your area changes depending on what your radius is. So that's all we mean by variation equation. So we're going to look at a couple of different types. So the first one we're going to start with is a direct variation equation, and it's written as y varies directly with x. So the way you would write this in equation form is y equals, for that varies directly, that's your constant of variation, is assumed to be there. It's not stated outright, but it's assumed to be there, just like we had pi for area equals pi r squared. And they use the letter k for this constant. So y varies directly with x, so k times x. So let's look at an example. A lot of times you don't know your constant of variation. You collect data and then you determine what your constant is. And that's what happened with area of a circle, that a bunch of people did a bunch of tests of circles and figure out what that constant was between the radius and the area of a circle. So let's look at this example. A skydiver's speed varies directly with the amount of time spent falling. Let's write this as an equation. When I have a word problem, I'm trying to pick variables that kind of go with the problem. You don't have to pick the exact ones I do. For speed, we'll use S, varies directly, equals K, and the amount of time spent falling. So I'll use T for time. So S equals K times T. That's the direct variation equation. Now it says, I've got a Y here, a skydiver's speed 2.5 seconds after jumping from a plane is 24.5 meters per second. So the speed, we're going to plug in 24.5. K is what I'm trying to find, knowing that it takes 2.5 seconds. At this point, divide both sides by 2.5 and you get K equals 9.8. Once you have this constant, I can rewrite this equation above and plug in the 9.8 for K. So that means for any time, I can now find the speed of the skydiver. So this is my variation equation. Okay, let's look at an inverse variation equation. This says y varies indirectly or inversely with x. So the equation for that would be y varies, y equals k, and then indirectly means you would be dividing by x. So that's the general form. And now let's look at a specific example. This says the volume of gas in a container at a constant temperature varies inversely as the pressure. So let's write this as an equation. I'm going to use V for volume. Varies, K, inversely as the pressure, so divided by P. I now am going to find K, so it says if the volume is 32 cubic centimeters, so that's my volume, at a pressure of 8 pounds. Okay, and then I'm going to stop there. I need to find K before I can even look at solving this last part of the problem. So I'm going to multiply both sides by 8 to get K, and we get K equals 256. So my equation is now V equals 256 over P. I now know my constant. Okay, so this is all similar to what we've done before. First we find K, then we write our equation. Now this one has an extra step. It says find the pressure, so find P, when the volume is 60 cubic centimeters. So we have an extra step. We actually know our volume is 60. We know 256, and we're trying to find P. Cross multiply, and you get 60P. 60 times P equals 256 times basically 1, so 256. Divide by 60, and you get P equals 4.3 pounds. So the pressure is 4.3 pounds. Okay, the next two, there's not one way to write a joint variation equation. There's many different examples. And so joint variation equation just means that you're going to have more than one variable. And so I'm just going to give you one example of a joint variation equation. This isn't showing every single equation you could see. So one example would be y equals kx z squared. Okay, so y varies in this case directly with x and the square of z. So you really need to read the equation or read the words to write out this equation that you might have. So let's look at this example. The area of a cylinder varies jointly. So first I'm going to write area varies jointly, so equals k, with the radius and the height, so it means it varies with r and h. Okay, so that's step one. I wrote the equation. Now we're going to find k. So when the radius is 3 and the height is 6, the area is 36 pi. So when the radius is 3 and the height is 6. So I'm going to find k, and I get 36 pi equals 18k. Divide both sides by 18, and I get k equals 2 pi. Now that I have k, I'm just going to rewrite my variation equation, but plug in 2 pi for k. So A equals 2 pi RH. Now this has a third step. It says, what is the area when the radius is 4 and the height is 5? So I now need to go and use my equation, so now that I found k, and plug in 4 for my radius and 5 for my height and find the area. And I get 20 times 2, which is 40 pi. So the area is 40 pi. Okay, same thing with combined variation equation. There's many different options. Combined means it could be any combination of direct or indirect and joint. You just have to read the words and write out the equation that you're given. So again, one example of combined would be y equals k times z over the square root of v. Okay, so y varies directly with z and indirectly with the square root of v. So it's one combined variation equation. So let's look at this example. It says the time needed to paint a fence varies directly. So time varies directly equals k with the length of the fence, L, and indirectly with the number of painters. So here's my combined variation equation, step one. Step 2, we now need to find K. So if it takes 5 hours, that's our time, to paint 200 feet of fence with 3 painters, how long? Okay, so now we're going to stop. I'm not going to answer the rest of that till I find K. So this is the equation I need to solve for. And when you solve for K, you get 0.075, or you can have it in fraction form. It doesn't matter. You'll have 15 over 200, which is 0.075. So I'm actually going to come over here and rewrite the equation. T equals 0.075 L over P. Okay, so that's our variation equation, now that we found K. So now we can answer, how long will it take 5 painters to paint 500 feet of fence? So we have 500 feet, so that's our L, and we're going to have 5 painters. We want to know how long so we can figure out how much this job might cost. And when you use your calculator, you should get 7.5 hours.